I hope you will stay with us for the roundtable session. I would like to give the floor to John. Great to have you with us, John.
Thank you. Sorry for the technical difficulties. Can you hear me?
Yes, we can hear you good.
And you can see the screen?
Yes, we can also see the screen. So everything is working. It's unbelievable.
Okay.
So where are you from?
I'm in New York, based right now in my basement, using my iPhone as a hotspot. So hopefully there's no air traffic during the presentation.
It is working for right now. So I'll give you the 10 minutes. Okay. Here you go.
Okay, let's go. So SHoP, I think a brief introduction. We're a New York-based firm, started projects locally in New York, and have increasingly our work has expanded globally. And our approach to technology is really about delivery. So a singularity of design and delivery, leveraging technology. It's about collaboration, it's about communication, and being very explicit about how projects are thought of, designed, and explained. So, we challenge convention, and there's no more conventional approach. With all the technology we have, how we work and how we think of spaces, it's still ultimately the drawing set. What architects do and what we feel we need to do is understand complexity, design complexity, and break it down to its constituent element. Understand how pieces and parts that make the whole are made, and how we explain the assembly process to achieve the built environment. And we leverage, we look towards other industry for this. We look at industrial design, automotive, aerospace are all intimately, aware of the design and its constituent part to the whole. And we believe architecture can be designed, manufactured, and assembled in a similar process. It requires an intimate understanding of the processes that create the design elements, and deep collaborations with the people and machines that produce the components. When you have that understanding and that sort of explicit relationship between design and part, it changes the deliverable. We start moving out of the two-dimensional drawing set, these thick packages of construction documents, as we know in the industry, and we start looking towards assembly diagrams, much more illustrative and accessible information, free of dimensions and tags. And when we do this, and we'll see if videos play over the hotspot, this may be a challenge. The interfaces, how we organize and operate our designs and communicate them, change. I'm not going to maybe this is playing. We start creating more accessible ways of deconstructing, calling out components, and manipulating and interacting with our designs. And this is something where we have now spent a lot of effort in creating what I'd call, UI, user interface for design. So how can we now take the projects with us in our pockets? How do we communicate them with clients, people that aren't necessarily three-dimensional CAD native? How can you interface with these projects and interact and provide feedback and understand them in intuitive ways? So our work is increasingly focused on these types of systems and data overlays. There are more videos in this, so this could be a challenge. I'll skip through some of these. But at the end of the day, we like to know exactly what is in our projects, the pieces and parts, individual components. Everything is labeled, everything has a name, and everything is immediately communicative from the design pipeline to the people, the machine installers, everyone that's involved, all stakeholders in the building. We realized early that we had to move out of the traditional AEC tool more towards industrial modeling and manufacturing PLM interfaces. And it's a DNA from the beginning of the office. This, first projects of Dunescape was understanding a three-dimensional form, but using the computer not to create form, but to extract that and create the infrastructure and information to build it. Time. The Porterhouse, as we scaled up the DNA of the office, become more sophisticated, right? CAD components and parts, to Barclays Center, which tools are exponentially more powerful. We have more control over hundreds of thousands of parts, and this is really a design to manufacturing and assembly approach. It's a prefabricated system. All pieces and components modeled in the computer, prefabbed, assembled, off-site, driven into the project and installed. And ultimately, what we realized is that from the design components, there's a immediacy from design moves. You should always understand to the part panel what the ramifications of your design moves are, and from that you can automate fabrication. You can communicate directly with, again, the people processing the information. And what we understood is it's actually geometric rationalization and creating parts and pieces is not really the challenge. I mean, it's hard, but that can be automated. It becomes much more of a logistics constraint. So how do you track, how do you account for hundreds of thousands of parts moving through dynamically a factory floor, let alone a multi-nodal supply chain? So we spun up web viewers. We created all these ways of tracking parts, barcode tracking, to understand the project. And this really laid out an infrastructure, a way of working that that's portable. So we looking at a project in Botswana, Africa, Gaborone, Botswana. We understand the digital infrastructure of how to achieve this. Hopefully this video plays. This is sort of an important one, so I will give this a second. Excuse me. But we start to understand our portfolio of projects, not from the part and piece, we don't reuse, but process can be reused. We start understanding our projects as a collection of processes. And this power of 10, we can move through the building, to the part, to the block, to the scope, to the trade, down to an individual facade component. And from that down to the bespoke panel that rationalizes a geometry in a piece. And the way that this works is it's not rocket science. It's this built on this agile wireframe of parts and pieces that you will then apply as you receive information from engineering, from manufacturing, material constraints, that you start applying pieces and parts to these flexible skeletons. And from there, you can create templates of process. So all the information necessary to manufacture, to communicate the design on the floor for assembly can all be encapsulated into templates and basically pasted around the building at a one-to-one scale. Information is accessible through online dashboards. Every piece and part is accounted for. We've rebuilt the tracking tools sort of from the ground up, moving away from third-party software to have control over data information and visualization. The idea of digitizing the site and context in real time to coordinate the build site from our desks in New York, and minimizing the deliverable, right? So the idea of this IKEA set, there's 3,000 unique panels on this. There's over 1 million parts. The only thing we delivered was an assembly drawing, similar to the one on the left, and solid part files for fabrication. They're indexed, they're tagged. The parking garage of the facility became a sort of pop-up assembly factory, a tier 1 plant. And you're able to achieve these results, sort of high-end, highly refined, high-tolerance parts remotely and with very little derivative byproduct for explanation, drawings, and such. I think I know I'm at time, but I'll add is that we're increasingly focused on centering, educating all of the stakeholders in the project's clients, subs, collaborators in focusing around this digital model. And I think what we're seeing is that through processes like product materials, CLT, which is a very healthy, sustainable material, it's a manufacturing manufactured good. This can be automated, can be machined and assembled. We're starting to look at how you manufacture the built environment and produce capital A architecture, and it's understanding data workflows, processes, and being in control of the design information. And ultimately, we do feel that design space is starting, our screens and our design environment is starting to be involved much more in processes of logistics and again, multinodal supply chain networks. And this is how we believe great design will be achieved in the future, in the near future.